Hey folks, Serdar here, and in this episode of Dev with Serdar, we're going to look at one of Python's most powerful modules that you might not know about, itertools. Everyone writes loops in their code. Itertools is a collection of functions for writing efficient loops, especially in scenarios where a simple loop by itself isn't enough. And this is a case where we want to dive straight into some examples, so let's take a look. Here is a common task we often have with loops. We have two or more iterables, like two lists, and we want to iterate through them to generate what's called the Cartesian product of the iterables. Like this, we have two sequences, A, B, C, and 1, 2, 3. And what we want to do is generate A1, A2, A3, B1, B2, B3, and so on. With itertools, we can do that very easily. We have the function itertools.product to do exactly that. We give it as many iterables as we want, and it will run through them in that sequence. Note that with each turn of the loop, it's generating a tuple with all of the elements across each of the iterables. So we could iterate through each of those in turn if we needed to as well. Another common thing we sometimes need to do is get all the possible permutations or combinations of something. And likewise, we have itertools.permutations and itertools.combinations for those jobs. Permutations is about how many ways we can order a group of things. And combinations is about all the possible selections of some or all of the values. So in the permutations example, what I want to do is generate all the unique ways that we could shuffle 4 letters. All we have to do is provide the 4 letters to permutations. Now, by the way, we could do this with a list or a tuple as well, but a string works because Python treats strings as a collection of things, characters, that you can iterate through. And with this, the result, as you can see, is all 24 possible unique permutations of A, B, C, D. Now with combinations, we provide a maximum length of combination sequences to provide, in this case 2. And we get all the possible unique combinations of elements with that many elements in each combination. So you'll notice that we get AC, but not CA, because combinations treats those two as the same result. They have the same elements, so we're just going to get whichever one is produced first. Note that if we use 4 as our combination length, we're just going to get back the original sequence. That's because combinations is about how many ways we can combine that many elements into a group. And there's only one possible way to combine all 4 of them into one group. So what are some good practical uses for these things? Well, for instance, let's say you're writing unit tests and you want to ensure that a series of functions all behave the same way, no matter what order they are called in, if you're worried about the sensitivity of the ordering. So you could use permutations to generate the test sequences. And for combinations, you could use that to test if calling only a subset of a given group of functions would be enough to generate a desired result. Some of the other elements in itertools are modifications of existing things in Python. For instance, in Python we have zip. This is a way of braiding together several iterables into a single stream. In this example, I've got letters and numbers zipped together and iterated through together. Now, here's a problem. What happens when the streams aren't the same length? Well, in this case, the zip iterator stops as soon as one of the streams is exhausted, as in this second example. We stop at 4. Because the shortest sequence is only 4 elements long. So what if we want to run this iterator for as long as possible until all the streams run out? Well, for that, we have itertools.ziplongest. The behavior for ziplongest is to swap in none for values from any stream that runs out, but it also lets us provide a fill value of any kind to substitute in. Generally, though, I find none works well for a common use case, so that's the default. Now, itertools has lots of other functions. I've barely scratched the surface of what's possible, but the basic idea should be clear. With loops or with iterating through collections of things, sometimes Python's built-in behaviors just aren't enough. And rather than try to stitch together a solution on your own, take a look at itertools. It's in the standard library, it's always available, and odds are there's something in there to match your needs. That's it for this episode. If you liked it, leave a comment below, and don't forget to follow Dev with Serdar and InfoWorld on Facebook, YouTube, and Infoworld.com.